Alright, we're going to go over real quick binary subtraction. We're going to keep this fairly basic. I'm going to be dealing with effectively two digits that we'll be subtracting, representing them binarily with ones and zeros, of course. Much like math, what we need to do is understand a few truths, okay, to make this work. First being that 0 minus 0 will render a 0, 1 minus 0 will equal 1, 0 minus 1. This gets a little bit unique. When you're trying to subtract from a 0, what's going to happen is we need to borrow values. So what's going to happen is 0 minus 1 will equal 1 with a borrow of 1. Then 1 minus 1 will equal, of course, a 0. So we're going to want to better illustrate this scenario. Everything else is pretty well understood. So let's write out our values. We talked about in math, for example, if we had two spots occupied within the same column that we couldn't really assign a value here, we needed to carry one. We needed to carry a value, because if we were to say if we had two digits here, two ones, it would be like saying 2 plus 2, and that equals 4. So we assign a 0 and carry a value over and represent it here. With the subtraction, it's a little bit different. We actually have to borrow from further down the line so that we can populate what otherwise would be a 0, so that we can make that work out. To give a brief illustration of that, let's say 23 minus 14. So the example basically standing here, in this scenario we can't go with a lesser number minus a larger number. What needs to happen is we need to borrow. We know this is the ones and then this is the tens spot. So if we bring this over, we can properly populate this by which we could subtract what otherwise was a larger number. So in this situation we're actually borrowing from the next column over. So what we say is that we make that a 1 and we bring this over as a 13. So minus 4 from 13 will equal 9. 1 minus 1, 1 minus 1 was 0. So this is basically the same principle we're going to apply on the binary side of things. But as far as subtraction goes, let's keep it fairly generic. Let's say we're only going to multiply or subtract two digits. So let's do fairly simple, but this will actually put most of the items in play. We have a 1 minus 1, 0 minus 0, and a 1 minus 0. 1 minus 1 will equal 0, 0 minus 0 equals 0, 1 minus 0 equals 1. See if that holds true. This should be 4 plus 1 equals 5, minus 1 should equal 4, and that is the case. Try another one real quick. So 0 minus 0, 1 minus 1, 1 minus 0, 0. So basically we did almost the same thing. Alright, but what we have here is we have 4 plus 2 equals 6. And minus 2, which gives 4. And that holds true. So now we're going to give ourselves a problem where we're going to have to work in this borrow. So we can better illustrate that. So 1 minus 0 is going to equal 1. Now we get into the scenario, 0 minus 1. So what we need to do is borrow. We know that this is the 2's column, and this is the 4's column. 1 of these equals 2 of these. So if we move this one over, if we strike that one out, basically we're going to bring this over as such. Alright? So it's like saying 2 minus 1 equals 1. Alright? Gonna see how we did that? So by bringing this over, that's like we're getting ourselves 2 minus 1. So 2 minus 1, we bring 1 down. This now assumes a 0 because we've taken that away. And then 1 minus 0 equals 1. I'll do it just one more time. This goes here, 1, 0. This will be a little more exaggerated, alright, because we're going to see a little bit of that ripple effect. So 0 minus 1, so we're starting off the bat where we need a borrow immediately. So we're going to actually strike this one over, and we're going to populate this. 2 minus 1 equals 1. Now that this is assumed as a 0, we need to borrow to make this correct. So we're going to take from here, and we're going to add it over. 2 minus 1 equals 1. So with this being 0, we jump right back into the same scenario. We need to borrow. Right. So 2 minus 1 equals 1, and we have zeros over here. So if we look back the way that it was originally established, looks like we had 16. We had 16 plus 4 plus 2. That equals 22. And over here we had 8 plus 2 plus 1. And we had 11. Okay, so it should have read 22 minus 11, which should render 11 as a result. So let's check our math. We have 8 plus 2 plus 1. In fact, that does equal 11, so our math does work out. So that's just a brief example of how we have to use that borrow when we are subtracting. We have to populate that field value so that we can maintain the structure. Alright?